Hey everyone, this is John Avina. I'm here with John Feldman. I'll tell you a little bit about what I know about him, but he's going to fill you in. I know a few things. He's super, super smart. He knows M&V, he knows energy engineering, and he used to teach the CMVP class. You're not teaching it anymore, right?
I do actually. I've come back. I've made a
He's
back from retirement.
Okay, and he is on the Association of Energy Engineers Hall of Fame. He's a Hall of Famer, and I think there's only 2 Canadians that are Hall of Famers.
That is correct.
So, okay, can you give a better or fill in a few cracks, like who do you work for, what do you do, and why should people listen to you?
Yeah, that'd be up for them to decide. But
okay.
So, name is John Feldman. I am educated as a chemical engineer, but I'm not a professional engineer. So certainly in Ontario, I can't call myself an engineer. The engineering police would come and smack me upside the head. But I do have a degree in chemical engineering. My current role is I work for the Independent Electricity System Operator here in Ontario, and that is well, it's essentially the IESO that runs the grid and the open market in Ontario. But the part that I work for is the Energy Efficiency Group, and I am the Senior Technical Officer for all our industrial programs in their various forms and in their various states. And where I got involved in measurement and verification is, and I will be transparent, I have never developed an M&V plan on my own, but I have reviewed many large custom projects, M&V plans, and have worked together with our vendor who does technical reviews to come up with strategies that both the customer and the IESO is comfortable with on the edge cases, or the ones that are weird and challenging. So I kind of have that perspective of M&V, and as you mentioned, John, I have taught the CEM. I'm the longest standing Canadian CEM instructor. I was the first, and I think the second one came 4 or 5 years after me. And I did teach CMVP for 5 years, and I'm back with a vengeance. Actually, in 2 weeks' time, I will be teaching the new material to a class here in Ontario. So that's kind of a little bit of what I do. Okay,
this is perhaps a question. Steve talked before about new material, and I asked him about it. I didn't know what it was. What's new in the new material in the AE
Nothing.
CMVP class?
Nothing.
Okay.
No. So there's nothing.
It's just that. Go ahead.
Yeah. So there's nothing. It's not new as in new fandangled ideas. It's a different way of presenting it, and I think that some of you will know from previous webinars what may have inspired the AEE to develop a new course, and we won't go down that rabbit hole. But a few things. The key I think the key fundamental newness of the material is that it is what's the word I'm looking for? Protocol agnostic. So kind of looking, when we did an analysis of what a CMVP, to have those letters behind your name, what should you be able to do? And so there was a kind of a fresh look at that, and so that's the one thing, is to say you should be able to be, given FEMP, given IPMBP, given ASHRAE, given the Saudi or the Dubai or the Canadian, whatever protocol, as a CMVP, you should be able to apply general M&V principles. So the material is much more structured around what are those general principles, and where are judgments called for, where do you make decisions about metering, about how do you go about M&V planning. And of course the material will references the various protocols at various times, but it's kind of trying to take that one step back, I think, is the one new thing. The other one, which I know there are some folks who have had challenges with how particularly option A and B have been characterized over the years. There's been some changing definitions, as it was spot measurement at one point, and then it was all parameters and key parameters. And the new material kind of introduces a kind of a slightly different way of looking at that, as to saying there's the retrofit isolation has, you either do it with well, don't remember this now. I was preparing last night. It's just sort of the option A would be performance. You just want to make sure that it's performing, and then option B is kind of more you want to do performance plus ongoing operations.
Okay, so option A is where you measure the first year and then you don't anymore.
Or you could measure for the first 5 minutes and not, but it's kind of option.
Yeah.
So, and again, it's not option A. Option A is IPMVP's approach. The CMVP is saying you need to understand that fundamentally in retrofit, there's two ways. Kind of, again, you could slice it 100 different ways, or maybe not 100, but a few. And the CMVP is saying is you could look at it as, are you only interested in making sure that the energy efficiency measure is performing the way it was meant to, or are you concerned about the ongoing performance and operations? And then the other quick thing, I'll just go down another rabbit hole, is instead of options C and D, it's, and I really like the way that this is to think about this, is option C is considered to using a statistical model, which is what option C is using, and option D is using a physical model. So getting away from the term calibrated simulation, and because, and again, another whole topic, option D in industrial, you don't have, building modeling software, but you do have engineering calculations. So you could, so kind of just looking at it as using physical models and using statistical models as two approaches for a whole facility.
Okay.
That's a nutshell what's new.
Yeah, that whole A thing has been confusing because sometimes some people consider stipulated as option A, and maybe they measured it once and then they stipulate it from then on for the next 19 years. But some people say option A means you still have to take measurements every year, and that's just confusing what's what and what does anyone mean by option A, but I think we have to live with it.
It did start off that way, and I think then there was at one point where it was option A was called spot measurement. So the focus was, if you're doing option A, you're just measuring for short periods. And I think the latest iteration, at least in IPMVP of option A, is that it's you measure one parameter and you estimate the others, but it doesn't talk about short-term or long-term metering. That's kind of up to you to decide. So we're kind of taking a step back from that with CMVP and saying, well, use whatever protocol you need to use. And actually, that which reminds me, there is one other. I suppose this is again, it's not new, nothing new science-wise, but the layering on, which is what we're calling, why can't I think of the name? External considerations. There's a better term we use that, but saying even the protocol FEMP or IPMVP generally, and this is kind of almost a segue into what you wanted to discuss, John, about uncertainty and things, is that the protocol doesn't provide the context in which it's living. If it's living IPMVP, if you're using IPMVP as an ESCO, there's different considerations that impact how you do M and V versus if it's, and again, there's more reasons to doing M and V, but the big split, the continental divide has always been, is it ESCO or is it a utility program? And a utility program provides a different context. It's ratepayer money, it's taxpayer money. There's evaluators involved.
The training is what you're saying, right? So let's go into that right now. So the question, this is real softball to start with, but why are utility programs, or how do they see M&V? Why do they see it like they see it? You understand how ESCOs do, and I think everybody here who's listening, I think almost all of them are ESCO people. They understand it. It's a contract. It's like, here's the rule of the game. This is how we're tracking savings. Based on these rules, we decide if we're going to write you a check or not. And that's about it. Did we meet our obligations? But with utilities, it's totally different. So I guess my questions are, could you tell me why you think it's different than the ESPC way? And then also, why is it different?
I can try. Well, first of all, I'm not as familiar with. I'm familiar with the ESCO model in theory, but not in
That's
practice. And I think it's kind of, again, and I can only speak from my IESO perspective, although I should remind everyone I'm not speaking on behalf of the IESO. I'm just speaking on my don't go and quote me to the Minister of Energy or anything. I'm speaking as a CMVP instructor who happens to work for the IESO and has knowledge of it. But kind of one of the things that, at least in Ontario, the government and the regulators are pretty sensitive to the fact that we're using ratepayers' money to incent people to do energy efficiency. And there's always, in any ratepayer or tax, I mean, we happen to be ratepayer funded. There are also taxpayer funded programs, but there is I won't say political will, that sounds too fancy, but there is a need not only to be doing, they always say, doing the right thing with tax ratepayers' money, but to be seen to be doing the right thing. So that's kind of a key driver. It's not, whereas in an ESCO, it's an individual contract arrangement between the energy services company and the customer, whereas from a utility perspective, you've got to look at all the customers and all the ratepayers and their funding, and be able to provide assurances or confidence or credibility to the ratepayers that money has been wisely spent, is the kind of thing, or has specifically delivered the energy savings that you believed it would do. And again, I only speak, I mean, that is a general statement for all the programs. Again, we have some prescriptive where, it's just deemed savings and everyone accepts it. Not everyone accepts, there's work that goes into providing confidence that those deemed savings and those were based on measurement at some point, or was based on some research. And on the other hand, with the custom one, it's down to the the nitty-gritty of an individual project. Does the ratepayer feel that money was, that the savings are real?
So basically, it's that the utility programs, and it's not just Canada and your organization, but I think it's utility programs across the board. They're taking money from somebody, the taxpayer, the ratepayer. And there's plenty of people who don't like energy efficiency out there, and who don't like taxes either. And they don't want to see our money being thrown away, thrown to these scoundrels who are just wasting it all and just giving it to their friends or whatever. That's how they might see it. And so they're looking over your shoulder. And I think that's part of what was involved. And so the utilities end up looking at certain things like, so you put in, I'm making this one up, you took out your old transformers, your distribution transformers, they were 20 years old. They probably would have lasted another 20 or 30 years. You took them out and put energy efficiency ones in. Well, that's a bad example. Here's a better example. I'm sorry. You changed out these package units and they were 20 years old and they were dying. Well, you were going to do it anyway. You put in these energy efficient ones that, but you were going to change them out anyway. So why should we, the taxpayers, have to pay them for energy efficiency when they were going to change them anyway? I mean, that I guess that's one of the terms they use is free ridership, right?
Well, there's free ridership, and there's why can't I think of the term? There's folks on the call, names directly. It's there's also early replacement. So there is a concept in utility programs where you don't get the full value, but if an incentive is replacing it earlier than you would have, and we do utilities have guidelines and rules in place to make sure that there's no free ridership.
They also have things like, okay, so it's only 10 years old. It would have lasted another 10 years. So maybe they'll do savings two ways. Maybe there's savings for the first 10 years is this way. And then after 10 years, they would get no savings, maybe because they were going to replace it in 10 years. So there's only 10 years worth of savings on that new unit or something like that. I've seen there's all kinds of complexity involved because they're trying to figure out what exact savings they're getting based on their money. I guess that's why they're different. And it gets really complicated, not necessarily PhD complicated. It just gets complicated. Sometimes there's too much thinking going on here.
I wouldn't deny that, and I think there's The other thing, though, that you kind of touched on, that is, it's it, it's not only the level of thinking, but it's putting the results in language that the ratepayer can understand. Or try to. You're trying to have to consider your audience to say, and again, that is a debate as to whether a ratepayer would understand uncertainty, but at least they think they do, because the general public are exposed to plus minus X% in various other contexts, and they believe they understand that. It makes them feel comfortable.
Okay, so all right, so we'll get to that. I want to get to that a little bit later. So, but basically, yeah. So we have this issue where we have, and another thing that the utility programs have, and I don't know about you in Canada, but out here in the United States, certainly in California, they'll have these programs. Let's say you had a hotel program where I'm a third party, and we do hotels. The utility pays me so many dollars or cents per kilowatt hour I save. Okay, so I get paid so many cents per kilowatt hour. I only do hotels. I go and I recommend a set number of ECMs, just a small number that I know are going to be easy, low on engineering, give me a great payback, and I'm going to end up making a profit. I mean, that's the idea. So I do all these calcs. Utility then will hire someone to look over the calcs and make sure they're right? Because I could always cheat them because I get paid per kilowatt hour. So we have one set looking over the calcs, and then they're turned in to the utility. And then there's, in California, there's a third party then which will look over the calcs again. Or the CEC, I think they'll look over a percentage of them. They'll look over them here and there. And it's like there's all this checking of calcs and rechecking of calcs, and it's so it's way different, let's just say, than the ESCO world. Yes, there are third party people who look over our shoulders sometimes, but not like this, not regularly. And also the utilities, because they have these, let's say, I don't know, because they're being, people are looking over their shoulders, they make rules. Like, this is how you will calculate. Let's say we're doing regressions, option C type M and V. They might say something like, yeah, you have to use this balance point on all buildings, always this balance point. Or so they'll make all these rules so that no one can game the system. That's the idea. Make it so no one can game the system. Yes, we're going to lose on the program won't be as good, the savings won't be as accurate, but we've prevented people from ripping us off and from causing a black eye for everyone. So you end up these utility manuals of how to collect savings, and some of them are really good. I mean, for energy engineers, guys doing energy audits, you'll find a lot of good information in there. But yeah, anyway. But yeah, I just wanted to make that clear. There's just a totally different world, a different, perspective, and different needs than the ESCO people. Yeah. And they need a lot more than we do, actually, in terms of instruction. They need so much more. I mean, really, if you were going to teach M&B to ESCO people and teach it to utility people, your utility class should be at least twice as long, maybe 3 times longer.
Yeah.
I think there's so much more involved. But maybe I'm wrong. And
no, I think you're right. And there's a few things. Just kind of the one just occurred to me now is that, kind of to my earlier point, that as an ESCO, you're established, and I think in the US also, you have to kind of, in Canada, you can call yourself an ESCO and it means nothing, but I believe at least my understanding is in some places in the States, to call yourself an ESCO, you need to meet certain requirements. But again, as an ESCO, you're an expert in energy efficiency. It's understood you've got a relationship with one client at a time, if I can put it that way. Whereas, from a utility perspective, you don't have that liberty because you're dealing with an entire market, much of whom are not energy efficiency expected. So instead of dealing with an individual customer, although we do on the large custom project, which is another story, but you're kind of dealing with that high volume. You have to be fair to everyone. You have to try and make it clear to everyone. And the other thing that kind of mentioned that made me think is, one of the realities of, at least where we're a government agency. We're not actually a utility, but I think utilities face the same thing. And there's this entity at least in our province called the Auditor General, who can randomly, either because they feel like it or because some ratepayers or taxpayers are suspicious of activity that's happening, will ask them to do an audit on a very specific thing. So that kind of, when you were talking about that, third and fourth parties looking and sampling at things, that's kind of, it's those sort of processes that are mandated by the Auditor General or have come out of previous audits, because you don't want to go to the tax base and saying, yeah, the IESO is trusting their third-party vendor to get it right. And you say, seriously, you're not checking on them? You're not making sure, sampling them or making sure that their work is correct? So there is again, at the ESCO, you've got a one-on-one relationship. Between the two of you, you can agree how much checking and QA QC has to do.
That's right. That's right.
We don't have that liberty, as a.
There's another thing that is involved in California, and it probably is where you are. I'm not sure, but certainly California, we've got grid issues because we have so much solar, right? And so,
Yep.
They're telling, I don't know if they're telling, I've heard this, I don't know if it's true, but that they're telling some solar producers or farms to shut it off sometimes when there's too much. I don't know if they're doing that or not. I know they do that in Texas with the wind, but in California, the goals of the whole utility-centric, let's say, energy efficiency approach, it's shifted a lot from just saving energy and saving money to actually reducing demand during certain hours of the day.
Yeah.
So it's acting, on behalf of the grid. It's helping the grid to, function better, and that's why they're using a lot of, interval data in California, and
Yeah.
they're really focusing on, let's reduce the demand during these hours because that's really where we need it, and that's really un-ESCO-like. We're just trying to save money to people.
Yeah.
It's just. Okay, so we have these two totally different orientations, but they're both in the same organization, EVO, and there's one manual or one guide like the IPMVP or core concepts or whatever that is for all of us, and that's what I think gets difficult because the ESCOs don't need a lot of that, and maybe. Maybe the utility people don't need some of that too. I don't know. I guess they do option A. That's probably what their deemed stuff is in a way. It's almost like option A. But
yeah, we have a range. Certainly the IESO, and I think that. Where was I going with this? We had a small custom retrofit program which was discontinued and is now going to be re-resurrected in a slightly different form. I think first or second quarter next year, but that had a kind of thresholds of, and I can't remember the numbers, but let's just say 40,000. If up for $20,000, up to $20,000, you could just use deemed savings. Between 20 and 80, you had to have like an option A, or it wasn't really option A. And again, this kind of brings back those, external considerations. Is there was actually for different, there was a guideline. So it wasn't truly IPMVP, but it was what was called basic M&V, which kind of said for smaller custom projects, measure a few light bulbs or whatever the case might be, or some RTU points. And then above 80,000, again, please, no one quote me on these numbers. They're not correct. And the program doesn't exist anymore. But, above, when they were really larger-ish projects, then there was what was called enhanced M&V, where you had to kind of, it was, I would say the basic was option A style, and the other one is more option B style, but they weren't truly IPMVP, A and B. And then with the work that I mainly do, which is on the very large, if I can put it that way, custom projects, the 1,000 megawatt hours kind of and above, we would generally use option B, or the IPMVP option B, and we have had some using option D, not the building modeling type, but the industrial modeling. And we have also had some option A, because if it's simply replacing a large piece of fixed load with a more efficient, a big large motor, maybe that's, you don't need to measure it continuously because it's a fixed load. And we've also used option C in some cases where it's been a facility where the gate meter, sorry, I'll use an example. I think of some of the wastewater treatment facilities where the air the air to aerate, damn, to aerate the ponds or whatever, represents 60-70% of the energy. So you can actually use option C because that's, you're going to cut that by 50%. So it's easy to. I can't remember what the question was, but that's kind of, we do use different, we try and use different things and different approaches for, the classic M&V, which is cost versus accuracy. How accurate do we or the ratepayers need things to be?
All right, so there's this uncertainty stuff, and I read you something. It was out of so this. I don't. Well, I'll bring it up. Let me see. I guess I lost my camera.
John, in case you were wondering.
I did. I'm back. I'm going to show my screen. Let's see if I can find it. Now, this is an older version, and they've. Oh, that's the wrong one. So I'm looking at the IPMVP uncertainty statistics guide, but this is the older version. They have since they fixed it, or let's say made it a lot better. But I want to show you, and I think I showed this to you already, but this. So it says, you can see this, right, John?
Yeah.
Okay, so it says, this is how we would say what our savings is to our client. The best estimate of savings is 1,000 kilowatt hours annually, with a 90% probability or confidence that the true average savings value falls within plus or minus 20% of 1,000. Oh my God. All right, that is confusing to me. Don't explain it to me. I don't want to know what it means. I mean, I do know what it means if I just went slower and slept a little more. But I mean, it does. You go and I'm sure this is somewhere in the newer version, but certainly not in 1.1. And but the main point is this is not. I don't believe this is useful to ESCOs in the least. But I could be wrong. But I really don't think so. But it might be for utility people, and that's what I want to know. What do you think about that? Is that something that you think is useful for utility folks?
I would say it's beyond useful. It is essential, but with a caveat. So one of the things, and this is not a position, this is a fact that. So there was another thing, so just a bit of background we hadn't spoken about before, but with utility programs, generally, those programs, put the auditor general aside, they, every year or every whatever period, they are evaluated by a third party, which might be a fourth party, which kind of looks at all the M&V and various other things and the processes and provides an independent evaluation of that. And those evaluations themselves look at either their sampling uncertainty, if it's a broad-based program, or I think, actually I can't remember the latest plan, but certainly in the early days of our large programs, each individual project was evaluated independently, and the uncertainty was calculated and reported to us, but we don't currently publicly report the uncertainty. We just report the savings. I spoke to our folks before this call, and they said, it's not, we're not hiding it. If people want to know what that it is, we will let them know. It's just kind of, it makes it harder to read. So I think and maybe I'll answer your question in a different way, is I think that the 90%, 20%, plus minus 20% is helpful. It's something to say. So let me put it away. I think if it's plus minus 1% or plus minus 25% or plus minus 30% is not stunningly helpful. But when you get to the point where it's plus minus 100%, plus minus 250%, and I have seen these, then any normal human being should be able to go like, yeah, we could have tossed a coin. We may have saved energy, we may have not. There's no way of telling. So I would be of the opinion, again, not an official opinion, me personally, that when you're under, and ASHRAE says I think 50%, although that's at a 68% confidence level, not at 90. You're probably, for two reasons. One, that's half of it's noise, half of it's real, but it's also one of the things that I keep beating the bush about is, and I know you'll devour this willingly, John, but statistics as a science is based on a normal well, two things. One is based on a normal distribution. Most of what we at least experience in with IPMVP and some of these others is assuming a normal distribution and assuming you've got plus minus. But for many, in my humble opinion, energy efficiency projects, there's no plus. If you put in a variable frequency drive and it's working, there's no plus. You can't have not saved energy. Maybe that's a bad example, but you put in an LED light bulb, you couldn't possibly have increased your energy. So I think maybe there's a branch of statistics which would help deal with that better. And there's also some places where there's not a normal distribution, which kind of is again
often, yes,
which is frightening because so in the sense that not only does the common engineer not understand that level of sophisticated statistics, but to my earlier point, how you explain that to the ratepayer is, I would find that challenging.
Well, that's the question, though. But you said that why do we? Okay, there's always oversight. We need to explain this in terms of ratepayer can understand, and then you end up with this description of, well, I'm 25% or I'm 80% confident the number's within 25% of this number. The ratepayer's never going to understand that. So who is it that has to understand that? Who's looking at that? It's not a politician. They won't get it.
Yeah, maybe there are better ways of explaining that, and I think that you kind of alluded to that in your articles, is that when you look at those definitions, and again, I'm just speculating now on the call, I haven't given this too much deep thought, but maybe a kind of, I wouldn't say a signal to noise ratio, but that's kind of what things like CVRMS are saying, is I've got a bunch of data that I measured. How much of that is actually related to the energy driver, and how much is related to just random stuff that happens in a building or in a pumping system that there's no way of predicting? And so I think that concept is helpful, that a layperson, or at least a person who understands enough about energy efficiency to be interested in it, would understand that we have, we're not 100%. Well, sure, again, I always find it difficult to talk statistical language, but or to try and talk statistical concepts in non-statistical language. But essentially, what you're saying is that there's, we know that there's a percentage of these savings which we know pretty confidently are from the measure and based on the energy drivers, and some it's just random stuff. And I think people in general would get a level of comfort if it's explained in that way, that yeah, we're living in a real world, there's random stuff that happens, but we kind of got a reasonable level of confidence that this, and maybe we need to layer on that the physics to say, yes, well, we know we put in a better light bulb, so we're pretty confident that we've saved energy. And the amount is, maybe it's some of it was manufacturing, each light bulb's got a different, slightly different power draw, and I think people can appreciate that. But overall, that money was invested well. We know we've saved energy.
So here's a kind of an offbeat question, and you might
refuse to answer. I'm kidding.
That's why I'm asking. I don't know the answer. So, and you might end up saying the same. Suppose you had a total random 12 months of data. We're looking at monthly data. It's random, up and down, up and down.
Yeah.
Doesn't really correlate to anything. And if you look at cooling, heating or cooling degree days, there's no slope. It's just random. Okay.
Yeah.
And so let's say you just took an average and said, okay, that's the baseline. It's this much. I know how much they use this year. This is the average. Or who cares about the average? This is the total. Then you install, let's say, a lighting retrofit, and for some reason you have to do option C. Okay.
Yeah.
I mean, I know you would measure lights is the right way to do it. Go option A or B, but let's say you had to do C, and they only did that. So, and the average value the second year after the lighting retrofit is lower. There's still all that randomness. We don't know what causes it, but it's lower. The question I have is, isn't that model good enough? I don't know that answer, but isn't that good enough? Maybe R squared of 0.02, and a CVRMSE of like 90% or some ridiculous number. But
yeah, well, that's the kind of scenario that would frighten the living daylights out of me, and where I think, I know we used to phrase this, and I probably still will, in CMVP, is that, again, kind of what I was saying earlier, is as an M&V professional, you want to understand the concepts, and statistics can be your friend to answer some of the data-based questions. And if you've got a random set of data, monthly bills or 2 years of bills, or even daily interval data, and you can find no correlation, and A, you can find no correlation, and B, as you say, let's say it's a perfectly flat curve, but the points are all over the place. I would not be comfortable taking ratepayers' money, to use an example, to pay someone for if that average is reduced, if I have no idea what's causing that, because and that is one of the things that the CV and your CV, or not in that, your CV kind of gives you a feeling for, how random is that data, or is it just kind of scattered a little bit about the line. So whether we report that number, whether people understand that number, to me as an energy management professional, if you have data that's completely random, that you have no way of either physically with the physical model explaining why it's doing that, or a statistical model, then this is I'm not going to spend my money on that, to say like, yeah, maybe you saved energy, maybe you didn't, maybe there was the moon and the planets aligned, and that's what reduced your power.
Yeah, or maybe there's just they keep hiring new people and firing new people, and some leave the windows open and some don't. And some thermostats and some don't, but they can't hold on to anyone long enough to have any kind of regularity. Who knows? And even if you knew that explanation, can you use that model? I mean, what if the data was higher and now it's lower? And whatever, we'll let that go. That your answer is very like what I heard once at a CPUC meeting, where someone asked, I mean, it might have been me, I don't know, but someone asked, well, what happened? What do you do with all the buildings where you can't get a good correlation? Because I was under the belief, and I still am, it's hard to get a good correlation with, interval data, because it's just, it's easier, I think, when you have larger intervals, like days, because all the weirdness moves out. And but these guys were looking at interval data. It's like, well, what do you do with those buildings where you just can't get a good fit? They're like, well, I mean, this is what they said then. I don't know. Maybe I'm sure they've evolved a lot since then. But back then they were like, well, we just won't do energy projects on those buildings. To hell with them. They're out. There's a lot of other buildings out there.
And that's the how do I put it? So we do have an energy, what we call an energy performance program, which is for buildings, and using option C, and not all buildings qualify. The model is not good enough. So for sure, if we can't get a good model, we won't accept that into the program. But the idea is, as in a kind of ESCO-esque type approach, is we measure the baseline, develop them, or the customer, well, let's say we, and there was create a baseline model, and then for over it's a contract for 3 years. So every year that you get paid every time. For persistent savings, I think it's now 3 or 4 cents a kilowatt hour. So you get paid 4 cents a year one if the savings is still there in year two. And what we have found interestingly is, sorry, first of all, the program requires hourly data, but we actually build typically daily models because, again, I'm an industrial guy, not a buildings guy, but there's kind of all sorts of thermal mass, and
Yeah.
some buildings have got, I mean, the one that was the most challenging was a building that we have a deep lake water cooling system here in Toronto where they take water from the bottom of the lake. That's at 2 or 3 degrees, and it's like pretty darn cold the whole year round, and circulate that through the buildings, which of course is not electrical. It doesn't impact the electricity use in that building because it's just it's a heat exchanger. There's no power. It's pumped from a central location. So that affects. So we found hourly models are not that great, but daily models are pretty good. And then we've also found, our third party that we've hired have come up with some pretty interesting independent variables or proxy variables, and occupancy measurements and things where there've been very few buildings from, I wouldn't say they've been, I can't even say it, I have no idea of the numbers, but there have been many cases where the initial model that the consultant or the participant submitted did not meet our CVRMSE requirements and model bias and a few other things. And we worked with them to try some things, maybe even simply as having a winter, summer models, a weekday, weekend, but yeah, our current program is if the model sucks and there's no way to make it unsuck, then we can't use ratepayers' money to help you.
Yeah. Okay. So one of the things that I brought up with you earlier, and it's also in one of my papers, is there's a lot of not talk, but a lot of the writing or literature in there is about option C and calculating uncertainty with option C and all that. And if the CVRMSE isn't good enough, which CVRMSE is kind of a brand of uncertainty in a way, if it isn't good enough, then you should drop option C and go do something else. But at least my thinking is that the something else often, not always, has worse uncertainty. Option A uncertainty is huge. You estimated stuff. I mean, how do you calculate that uncertainty? I don't know. I think you have to measure things to calculate the uncertainty, but maybe I'm wrong. And option D, the uncertainty is huge. And then option B, yeah, you can calculate uncertainty on some of the easier option B, but when it gets a little harder, then, I mean, think about it. If you're doing a brand new chiller, and you're doing a chiller model, so we want to know kilowatts per ton. All right, so to get tons, what do I need? Chill water supply, chill water return, GPM. Okay, well, did I put my GPM meter far enough away from the bends in the pipe?
Yeah.
I don't know. I hope so. Am I really sure? How certain am I that there's laminar flow there? How do you put a number on that? Okay, but then there's also, you have all this interval data, and you end up with negative tons some hours. Well, how does that happen? I have negative tons some hours, or I have kilowatts per ton. I have 10 kilowatts per ton this hour. You end up with data that just doesn't make any sense when, maybe the chiller just turned on, or maybe, it's a really super low load. You end up with really crappy data, and people who are, doing this M&V, they throw it out. Well, how do you deal with that? I mean, how do you calculate uncertainty for a chiller model like that? And then you're using TMY. Let's say we use the TMY data, to do this. And it's like, well, where's the certainty there? The TMY, first off, you can say, well, that represents an average, data set of weather. But if you look at TMY, TMY2, TMY3, I saw some guy give a presentation showing that the temperatures keep going up. That it's warmer. Each version of TMY gets warmer. So what's my uncertainty that TMY3 is good enough and is representing what's going on now, because TMY3 is pretty old? Shouldn't there be a TMY4 that's warmer than that? Where's my certainty there? So how do you ascribe uncertainty to this stuff? And so, and then they're saying, well, yeah, but the CVRMSE is, more than savings is twice or whatever, CVRMSE or whatever. Yeah. Therefore, option C, it's like, but that is really probably the best way to estimate savings. Not in all cases, but I don't think that CVRMSE, that number is necessarily should be a disqualifier like that. Go ahead. How do you respond to that?
Yeah, well, that was a lot, John. But I'll respond to some, which I know about, and the ones that I don't, I will avoid. But I think you and I discussed, certainly for our custom programs and our large custom sorry, not for our custom, the large custom program, we calculate uncertainty for option B. We've had very little option A. Well, with option A, whatever the metering is involved, the accuracy of that meter would factor in. For option B, we have certainly rejected some projects where the baseline model, even of a large fan or a compressed air system, if the baseline model as the basis for adjustment is not acceptable, we once our hands are tied, but we've had, we haven't been able to make very few. Most of them we've been able to. And again, I think probably everyone on this call at least has dealt with IPMVP and MNV, is aware that the from an option B and option C, the greatest uncertainty is not the metering, it's the model. In other words, how, as we kind of alluded to earlier, how well does the energy driver, the independent variables, predict energy use in the past, and therefore we can rely on it in the future. And I think again, a lot of this uncertainty and statistical information, and where it's difficult, is about one of the principles around certainly stated in IPMVP and MNV in general is transparency. I think that's, maybe I'm making that up. Anyway, it's a principle for me, is at least if you say this is a deemed savings and it's based on research, or this is an option D that's based on engineering calculations, no measurement was done, that again, not because we don't have that one-on-one relationship, but at least the market or the ratepayers understand what the basis is. And it's kind of, to me, if you can't get it great, then at least explain the assumptions you've made, where you've and what you've done is vital. And the part of the reason I'm saying is that we have had some option D, as I said, in industrial projects, large projects, where to use your words, but where the uncertainty isn't real, in the sense of, it's real is maybe not the right word, but you didn't build this one thing, so you didn't measure anything, so there's no real uncertainty there. And you did measure post, so there's some metering error there. But with option D, the biggest, at least in our experience, and we've done a few of these projects, is unlike buildings, in industrial option D, the base case is what the customer convinces you that they put in. They would have put in if they didn't have your money. So that's the one side. So we have had customers who said they would buy a really like the cheapest piece of junk chiller equipment that they can get, and it's on the market, you can buy it, so it's hard for us to say no, that you're being crazy. So uncertainty, the incentive is based on what they have decided, is primarily based on what they have decided the base case is. But the other view that I take on the other side of that, where no matter what the uncertainty is, what I'm certain about, pardon the pun, is if it would, I can't think of a strong enough word, it would break my heart if a customer went ahead and put in some cheap junk when we had the opportunity at the new purchase to influence them to put in something more energy efficient. Even if we're not really sure how much energy is saved, the fact is they did something more efficient than they would have if we hadn't been if the ratepayer hadn't helped them. And that's for me, option D is the bottom line. It's not about measuring exactly how much you would have saved, because that's kind of, I won't say fictitious, but it is kind of, the actual number is somewhat fictitious, but it's again, it's not plus. We know it's minus.
All right, I got two. I'm going to answer, or not answer, I'm going to bring up some questions. So people have asked a few questions. So here's one. So the 2016 statistics guide in ASHRAE 14. So that's the 2016. That's the old one. That was the one I was looking at, right?
Yeah.
Okay. Recommend. Not ASHRAE. Well, ASHRAE 14 didn't say what year,
Yeah.
but I'm assuming he's going to say the new one. Recommend an acceptable uncertainty is plus or minus 50% at 68% confidence level or less. So savings is greater than 2 times standard error. Is this acceptable for a single project from a utility company's perspective? Multiple projects in a portfolio will reduce the overall uncertainty. Right. See, that was something I didn't interject also when you're talking about uncertainty and you have high uncertainties, but you add them all together, you have this whole portfolio and then they're all going to compress.
Yeah.
But that aside, his question though was, is that good enough that 68%, 50, so uncertainty plus or minus 50% at a 68% confidence level or less. Is that acceptable for a single project from the utility company's perspective? Well, you can only talk about your own. Yeah, I guess that was the question.
Yeah, and I would say it depends. Again, for our large custom projects, we typically actually look for 50% at the 90% confidence level, because all the work we do in option B is around the 90% confidence level, which again is, you get to choose what you want your confidence level to be. And certainly we work on the principle of savings greater than twice the standard error. Which is the challenge, but the reality of that is we can only estimate the uncertainty. And well, we have had a few situations where the actual uncertainty went off the charts, and we have had to have some awkward discussions with the customer to try and figure out how we can, better assure the ratepayers that the savings are real before we pay out the money. But most of our projects have generally come in well below that. There was one actually recently, which is kind of, I'm feeding into John's was it passion about the math and statistics behind this, but we had a project where it underperformed, and the original estimate of uncertainty was plus minus 26%. But because the program underperformed, they only saved about half the energy they wanted to. Because that's a smaller percentage, the uncertainty goes up, and it went up to plus minus 60%. So it's kind of like, well, now how do we deal with that? Because if the project's performed, it would have been plus minus 26%. Everyone's kind of happy it's below the 50. It's not too awkward a conversation.
That is an interesting question, because when we do fractional savings uncertainty, it's based on what we expect we're going to save. Yeah. So what happens when we save less? Does that mean we have to recalculate uncertainty? I don't know that answer.
We do. We have to report, the projects have to report their uncertainty, the actual uncertainty. What we do with that is a little bit more but
then you end up in this position where you funded it, it saves less, and now no longer meets the uncertainty threshold.
Yeah. And I'm not at liberty to discuss how we deal with that.
But we have conversations. So do you have any last words? Any last words, I guess?
I guess my last words, and I think we'll come back to what John maybe what I'd alluded to earlier, is that I think that uncertainty is a helpful tool, a statistic tool, if applied with understanding and is I think it helps the utilities and the energy engineers to understand what the data is telling them, and what's likely noise and what's not likely noise. But I think we as a community can do a better job, or should be doing, or should be looking at ways to do a better job of communicating that to ratepayers and other interested parties in a way that you don't have to have a degree in statistics to understand what it's saying. Now that might be an impossible mission, but
you guys you're smarter in Canada than we are in the United States. I mean, I think if you look at our math scores, you'll see it. But you're not going to explain it here. Right? No. It's not gonna work. Okay, but I heard what you said, and they did too, and I'm sure most of them agree with you. Okay, you guys, thanks for coming. I appreciate that you come every month. Take care. Thank you.
Thanks, John. We'll see you.